Hello everyone, welcome back to my chemistry page. Today we are going to discuss another set of three questions from the first lesson, chemical reactions and equations. So let us try one by one. The first question is, describe an activity to observe what happens when quicklime is added to water taken in a beaker. State two important observations and name the type of reaction taking place. So basically you need to write an activity when quicklime is added to water. You already know that quicklime is white color. So consider this as quicklime. And it is white in color. And when you sprinkle water on quicklime, so this is water. And when you sprinkle water on quicklime, large amount of heat is produced. Which means that this is an exothermic reaction. Quicklime formula is CaO because it's calcium oxide, and quicklime now after the reaction it is converted to Slackert lime, and Slackert lime is calcium hydroxide. So this is the basic formula for this reaction. And whenever you are getting a question like this, you need to write this activity in the form of an experiment. What is the form of an experiment? You need to write it as aim, materials required, procedure, observation and conclusion. This is the format of a experiment. Now let me try to write that one. So first of all I am going to write aim of this experiment. What is the aim of this experiment? To observe what happens when quicklime is added to water taken in a beaker. Now, to do this experiment, what are the materials required? That is your second step. Materials required. We need quicklime. It's also called calcium oxide. Quicklime. Then you need water and a beaker. The third step of this reaction is procedure. How are we going to do this reaction? That is called the procedure of this experiment. Whenever you are writing a procedure for an experiment, you need to specify the amount of substance needed. For example, for this quicklime, I am just taking it as 10 gram. So you write, take 10 gram of calcium oxide in a beaker. Then, what is the second step? Add water to it. Add water slowly. Third one, observe it carefully. And note down your observations. So this is the simplest procedure for this experiment. After writing procedure, the next step is to write the observations. So what is observation? I already told in the beginning of this experiment. Whenever you are adding water to quicklime, a lot of heat is produced, and this is an exothermic reaction, and the product is Slackert lime. Slackert lime is called a calcium hydroxide. So that is your observation. Observation. First observation is large amount of heat is produced. Large amount of heat is produced. Second observation is calcium oxide reacts vigorously with water and calcium hydroxide is formed. Calcium oxide reacts vigorously with water and calcium hydroxide is obtained. Now, after observation, you can write the conclusion. What is the conclusion of this experiment? What is your conclusion? The reaction between calcium oxide and water is a combination reaction. It is an exothermic process because heat is evolved. So you can write your conclusion now. The reaction between calcium oxide and water is a combination reaction and it is an exothermic process. And you can write your equation also. Calcium oxide plus H2O produces calcium hydroxide. The calcium oxide is a solid substance and water is liquid and the calcium hydroxide is aqueous. And large amount of heat is also produced. Heat. So this is the first question. Now, let me try to go to the second question. Second question is, what is the color of ferrous sulfate crystals? Ferrous sulfate. Ferrous sulfate crystals, it is green in color. Green in color. How does this color change after heating? So when you heat ferrous sulfate crystal, how does this color change? So when you heat ferrous sulfate, it is converted to ferric oxide. And the ferric oxide is this is brown in color. Brown. Okay, this is the first reaction. So when you heat ferrous sulfate crystals, which is green in color, it is converting to ferric oxide. Ferric oxide is brown in color. Now, the second step of the reaction is name the products formed on strongly heated ferrous sulfate crystals. What type of chemical reaction occurs in this change? We need to write the products formed when strongly heating ferrous sulfate crystals. The products obtained are ferric oxide, and you will get sulfur dioxide, and this is gas, and then you will get one more product, that is sulfur trioxide. Sulfur trioxide, that also gas. And the last question is, what type of chemical reaction occurs in this change? And this is actually, the decomposition reaction, and it is thermal decomposition. So the type of reaction is thermal decomposition. Thermal decomposition. If you want to write a chemical equation, the equation should be in this form: FeSO4 on heating. The products are Fe2O3, that is ferric oxide, then SO2, sulfur dioxide, and SO3. SO3 is sulfur trioxide. Sulfur dioxide is gas, sulfur trioxide is also gas, and Fe2O3 is a solid substance. Even FeSO4 is also solid substance. Now you need to balance this equation. I'm just putting 2 over here because on reactant side we have 2 Fe. So 2 FeSO4, you will get the products Fe2O3, SO2 and SO3. Look at this image. This is the actual ferrosulfate crystals. When it is heated, it is changing to ferric oxide. It is brown in color. Now, third question is, using balanced chemical equation, explain the difference between a displacement reaction and a double displacement reaction. You already know in a displacement reaction, more reactive metal can displace less reactive metal from its salt solution. So usually during displacement reactions, more reactive metal displace less reactive metal from the salt solution. Now, so to do this kind of reactions, we need a reactivity series. So you should have an idea on what is reactivity series and how the metals are arranged in the reactivity series. So in the reactivity series, all the metals are arranged according to the reactivity in the decreasing order. So when you look at this reactivity series, you can see that potassium is coming in the topmost position because it is the most reactive metal. So when you come down, the reactivity is decreasing down. So which means that the most reactive metals can displace the less reactive metals from their salt solution. For example, if you are considering potassium and sodium, potassium can displace sodium from the sodium salt solutions, or calcium can displace magnesium from the magnesium salt solutions. So basically what we are meaning, like if you have two metals in your hand, the high reactive metal, so that we say more reactive metal, it can displace the less reactive metal from its salt solution. This is the idea of displacement reactions. So you already know we have two kinds of displacement reaction. The first one is simple displacement reaction, and the second one is double displacement reaction. In simple displacement reaction, only one type of displacement is taking place. For example, if I am taking magnesium, the most reactive metal, and you need to take the less reactive metal as any of the metal which is coming down from magnesium. I'm taking copper here, copper sulfate, because we need to take a salt to solution. So magnesium metal, when we put in copper sulfate solution, and this is blue in color, the more active metal can displace the less reactive metal. So basically we are comparing the reactivity of two metals over here. So which are the two metals present here? Magnesium and copper. And when you look at the reactivity series, you can understand that magnesium is more reactive than copper, which means that magnesium can displace copper from the copper sulfate solution. So copper will be displacing from the solution. The remaining part is MgSO4. Alright. So this is the simple displacement reaction between magnesium and copper sulfate. You can write any kind of metal according to your choice by looking at the reactivity series. Only two things you need to remember in your mind, that one should be a more reactive metal and the other should be a less reactive metal, so that you can compare the reactivity of two metals accordingly. Now, I'm just moving on to the second part of the question, that is double displacement reaction. In double displacement reactions, exchange of both kind of ions are taking place. For example, I'm taking silver nitrate and sodium chloride. One easy example for you. Silver nitrate, AgNO3. Silver nitrate. Silver valency is 1. Also nitrate valency is 1. So if we exchange both, you will get formula as silver nitrate. And when it is reacted with the sodium chloride, EC compound in chemistry, NaCl. The sodium and the chlorine valencies are 1. So the formula will be NaCl, sodium chloride. In this double displacement reaction, the ions between atoms are exchanging. Sodium is exchanging its chloride ion with the nitrate, and silver is exchanging its nitrate ion with the chlorine. So what you will be getting, like sodium nitrate. Sodium is going to combine with the nitrate and the silver is going to combine with the chlorine. So you will get AgCl, silver chloride as a precipitate plus NaNO3. Sodium nitrate is actually dissolving in water, so I am writing aqueous over here. But in the case of silver chloride, it is insoluble in water, so it will be obtained as a residue. So we can write this as a precipitate. So this is a precipitation reaction also. This is silver chloride, and it is obtained as a precipitate in the reaction. So this is one easiest example for double displacement reaction. So what you understood in double displacement reaction? When two compounds exchange their ions to form two new compounds, we call it as a double displacement reaction.